Graphing absolute value functions. So absolute value graphs are V-shaped. Okay, so they almost actually have some sort of similar properties with the quadratic functions because quadratic functions were the U-shape. Absolute value though are V-shaped. So here's like a little table of it just to make you understand. Like the absolute value of -3 is +3, right? And the absolute value of -2 is +2. The absolute value of -1 is +1. The absolute value of 0 is 0. The absolute value of +1 is +1. The absolute value of +2 is so this is how it looks. Like at -3, it's at 3, at -2, it's at 2. The absolute value of these so that's why it looks like a V. So all absolute value graphs are going to have that sort of V shaped, okay, V shape. But what we're going to do is we're going to put some sort of like alterations on it or factors and shifts that are going to move it or going to make it more steep or less steep. So we're going to alter these absolute value equations. So on A, I'm going to do all of number one with you. So on A, this isn't just a normal absolute value equation. We've multiplied it by 2, and then we've also done a subtraction of 5. So let's see how this absolute value function looks after it's multiplied by 2, and it's got a little subtraction of 5 on the back end. So let's fill out the table for this, okay? So I'm going to do most of this like verbally because I don't want to write it all out. If you want to write it all out, go for it. But I think we might be able to do some of this kind of in our head to do a little quicker. So let's plug in -3. So the absolute, so that's, remember, these are all going to go in for x. So the absolute value of -3 is +3. 2 times 3 is 6, and 6 minus 5 is 1. So 1 goes there. Okay. Now I'm going to plug in -2. And again, I'm just kind of doing this in my head. The absolute value of -2 is +2. 2 times 2 is 4, and 4 minus 5 is -1. Okay, now I'm going to plug in -1. So absolute value of -1 is +1. 2 times 1 is 2. 2 minus 5 is -3. 0. Absolute value of 0 is 0. 2 times 0 is 0. 0 minus 5 is -5. Now let's plug in 1. The absolute value of 1 is 1. 2 times 1 is 2. 2 minus 5 is -3. Substitute 2 in there. The absolute value of 2 is 2. 2 times 2 is 4. 4 minus 5 is -1. Now let's substitute in 3. Absolute value of 3 is 3. 2 times 3 is 6. 6 minus 5 is 1. So now I have a table. So at -3, it's at 1. So I'm going to graph this now. At -2, it's at -1. At -1, it's at -3. At 0, it's at -5. At 1, it's at -3. At 2, it's at -1. And at 3, it's at 1. So this is what this function looks like. Looks like this V. So if we're trying to like look at the original absolute value function, if you kind of looked at the original absolute value function, what you're going to see is it just kind of goes like up 1 over 1, right? But now this one looks like it goes up 2 over 1, up 2 over 1. It looks kind of like it has a slope of 2. And you can probably look at the equation and understand why, because look, this 2. So that number kind of determines the slope. That number determines the slope. Now, if you look at the absolute value original one here, it just starts at the origin, right? At 0, 0. This one doesn't. It starts at -5. It starts down. It starts 5 below, and you can probably see why because of the equation, because of this -5. That's why it starts down there. So that number in front kind of determines the steepness of it, and then that number outside of the absolute value determines, like a shift down is what I'm going to say, kind of a shift down, okay? So let me play around with this one real fast. Okay, so I'm going to substitute in -3 first for x. So in the absolute value bars, you treat it like parentheses. You're going to do what's in there first. So -3 minus 3 is -6. Absolute value of negative 6, positive 6. 1/2 of positive 6 is 3. Now I'll substitute in negative 1. Negative 1 minus 3 is negative 4. Absolute value of negative 4 is positive 4. 1/2 of 4 is 2. Now let's substitute in 1. 1 minus 3 is negative 2. Absolute value of negative 2 is positive 2. 1/2 times 2 is just 1. Do 3 now. 3 minus 3 is 0. Absolute value of 0 is 0. 1/2 times 0 is 0. Let's put in 5. 5 minus 3 is 2. Absolute value of 2 is 2. 1/2 times 2 is 1. 7. 7 minus 3 is 4. Absolute value of 4 is 4. 1/2 of 4 is 2. Let's use 9. 9 minus 3 is 6. Absolute value of 6 is 6. 1/2 of 6 is 3. So I'm going to graph negative 3, 3. Negative 1, 2. 1, 1. 3, 0. 5, 1. 7, 2. And 9, 3. So let's look how this one was affected. The slope on this guy looks like it's going up 1 over 2, right? Up 1 over 2. That's indicated here. So again, that kind of indicates the slope of this thing. Then it says x minus 3 within the bars. And how that's shown is that, remember, the original absolute value, it started at the origin. But this one starts at positive 3. So where it shifted horizontally is indicated by this. And the opposite way. It says minus 3, but it's actually shifted to the right 3. So it's the opposite inside that absolute value bar. And we've kind of seen that relationship with the vertex with quadratic functions. I'm actually going to skip C. If you want to fill out that table yourself, go for it. Actually, maybe not. Let me do C also. So I'm going to start with negative 4. So I put negative 4 in here. Negative 4 plus 1 is negative 3. Let me write this one out just because so negative 4 plus 1 is negative 3. The absolute value of negative 3 is positive 3, but there's that negative in front, right? So I'm going to have negative 3 there, plus 4 is positive 1. So this is 1 here. Let me do negative 3 now. I'm going to erase that, but that's what I'm doing. Negative 3 plus 1 is negative 2. Absolute value of negative 2 is positive 2. And then there's a negative in front, so it's going to be negative 2 plus 4 is 2. Negative 2 plus 1 is negative 1. Absolute value of negative 1 is positive 1, but there's a negative in front, so it's going to be negative 1 plus 4 is 3. I know I'm being crazy. I'm talking really fast, but plug in negative 1. Negative 1 plus 1, 0. Absolute value of 0 is 0. There's a negative in front, doesn't matter. Negative 0 is just 0. 0 plus 4 is 4. Now let's plug in 0. 0 plus 1 is 1. Absolute value of 1 is 1. There's a negative in front, so it's going to be negative 1 plus 4 is 3. Plug in 1. 1 plus 1 is 2. Absolute value of 2 is 2, but there's a negative in front, so it becomes a negative 2 plus 4 is 2. 2 plus 1 is 3. Absolute value of 3 is 3, but there's a negative in front, so it's negative 3 plus 4 is 1. Okay, negative 4, 1. Negative 3, 2. Negative 2, 3. Negative 1, 4. 0, 3. 1, 2. And 2, 1. So this, what this one looks like. Now this is interesting because it's an upside down V. And it's kind of got a slope of 1, right? It's just going down 1 over 1, down 1 over 1. Where is that indicated in the equation? the negative in front. See that negative in front? And this is technically like a -1, right? There's no coefficient. So that's why it's an upside down V, because the negative coefficient out in front. And it's just going down 1 over 1 because it's just a -1 sort of. I'm just going to call it slope there. That's why it's upside down. Now the vertex of this thing, I'm going to bring in the idea of vertex, is at 1. Oh, actually -1 is at -1, 4. So comparatively to the original, which started at the origin, it's 1 to the left, which is opposite of this +1 like we were talking about, and then 4 up. So that's where it's indicated there. So this whole table creation, all this long talking I've been doing, I hope it didn't feel like a waste of time, but the whole point of this was to derive the next page, because you're going to be able to graph these absolute value functions without making this big old table. So let's get into it. Let's do it. Next, we'll graph absolute value functions without creating a table. So this is the general form that the absolute value functions will be written in. A absolute value x minus h plus k. It looks a lot like vertex form, doesn't it? Where you had that a and then the parentheses, and then we have that number outside of it. It's the same thing. So it's like opposite of this, and then this, that's our vertex. And then that the A just tells us kind of the steepness and the slope, okay? I'm going to use the word kind of slope here. So on A, this is how it's going to work. The vertex opposite of the +3, which would be -3, and then -7, that would be the vertex. So here. And then the slope, whoops, I plotted that way wrong. What am I thinking? -3, -7 is down here. And then the slope is just 1. There's no coefficient right in front, so it's just 1. So it's up 1 over 1. But it's a V, right? So it's still going to be like this way. It's going to show that steepness from that point. It's going to go this way in both directions. And it should open up because it's a positive slope, +1, +1. Let me show you B. Okay, the vertex on this one, remember it's opposite of that. So it's going to be +5, 1. So here. And then this slope is just like a -1. So that means it's going to open down. It's going to go down 1 over 1 like this. So that's good enough. Sorry, my line's really wiggly. Okay. So let me do a couple more. So this is a lot better than making a table, right? We can just use this sort of stuff, these notes up here to determine where the vertex is and which way this is going to open and the slope. Okay. So opposite of -2 is +2. Then I have -4. So 2, -4 would be where the vertex is. Now the slope, though, is 3 and a positive at that. So I'm going to go up 3 over 1 from that point. So it's going to be quite steep. That's how that's going to look. Last one, vertex, or for me that I'm going to show you, and I'll let you try some after this. +4 and then 3. Slope is -1/2, so I'm going to go down 1 over 2. It's going to go like this. Okay. So that's how you graph it without a table. We just identify the vertex and identify kind of how the slope's going, and and plot from there. So I'm going to let you do all these ones. And I'm going to do a few of these for you. Yeah, I'll do a few of these. So it says write the equations for the following graph absolute value functions. Okay. So remember the form for this would be, I'm just going to use y. Y equals a x minus h plus k. Remember, hk is the vertex, right? So our first step, we did to determine the vertex. This looks like it's at -1, -5. And now let's kind of try to find what the slope is. So if I look at this slope, it looks like it's going up 3/1, right? It's going up 3/1. It's positive, right? I mean, it's opening up. So to write the equation, I would say y equals 3, absolute value, opposite of the -1, so it would be +1. Oh, whoops. And then subtract 5. Let me show you another. First, I'm going to find the vertex. Looks at about 2, 6. In terms of the slope, it looks like it's going down 1/1, down 1/1, down 1/1. So when I write this function, I'm going to say y equals negative, and I could put a 1 there if you want, down 1/1, but I'm just going to just negative, and then x minus 2 is opposite of the positive 2, and then plus 6. Let me show you one more. Vertex here looks to be at 4, -3. And the slope of this one seems to be going up 1/2, up 1/2, up 1/2. So y equals 1/2 positive, right? It's opening up. X opposite of the 4, so subtract 4, and then -3. So I'll let you do the rest.